Before the dinosaurs, before the world as we know it, there was a time of immense struggle and strange beauty. This was the Permian Period. It began nearly 300 million years ago, a chapter in Earth's history that would end in the planet's greatest catastrophe. The world was a single vast stage, upon which life's drama was about to unfold under the harshest of conditions. To understand this time is to look into a mirror of what our planet can become when its delicate balance is pushed to the very brink. The Permian was not just a bygone era, it was a crucible, a testing ground for life itself. The Permian followed the Carboniferous period, an age of lush, swampy forests that had laid down the coal beds we use today. But the world was changing. The land masses, which had been scattered across the globe, were slowly, inexorably drifting together. This monumental geological dance would set the scene for everything that was to come. The climate began to shift away from the damp, tropical conditions of the past. A drier, more challenging world was emerging, one that would demand new and remarkable adaptations from the creatures and plants that called it home. This was the beginning of a new era, one defined by its severity. Picture a world so different from our own. The air was thick, and the very ground beneath one's feet was on the move. The Permian spanned an immense amount of time, lasting for over 47 million years from about 299 to 252 million years ago. During this vast stretch, life diversified in extraordinary ways, yet it was always under pressure. The challenges were immense, from the sheer scale of the landscape to the increasingly unpredictable climate. It was a time of giants and strange reptilian pioneers, all locked in a constant battle for survival against an environment that was becoming progressively more hostile. This period serves as a profound reminder of our planet's dynamic and sometimes violent nature. It was an age where the rules of life were being rewritten by powerful geological and atmospheric forces. The story of the Permian is not simply one of ancient life, but a cautionary tale of environmental change on a planetary scale. As we delve into this lost world, we can witness the incredible resilience of life, but also its profound fragility. It was a world teetering on the edge, a prelude to an event so devastating it would nearly extinguish life on Earth entirely. The defining feature of the Permian world was the supercontinent of Pangaea. Imagine all of Earth's continents from Africa and the Americas to Asia and Australia, crushed together into one colossal landmass. This enormous continent stretched from the North Pole to the South Pole, creating an environment of unprecedented scale and severity. With so much land concentrated in one place, the moderating influence of the oceans was lost to vast interior regions. This geological arrangement was the primary driver of the Permian's extreme climate, turning the heart of the world into an immense and unforgiving desert. The creation of Pangaea had a dramatic effect on global weather patterns. Moisture-laden winds from the vast Pangaean Ocean, which surrounded the supercontinent, could not penetrate deep into its interior. As a result, the heart of Pangaea became incredibly arid. We see evidence of this today in the extensive red bed sandstones and evaporite deposits from this period, which are hallmarks of ancient deserts. Life in these regions had to contend with scorching daytime heat, freezing nights, and a constant desperate thirst. It was a land of stark contrast where survival depended on the ability to endure long periods of drought. This new continental arrangement also changed the oceans. The formation of Pangaea drastically reduced the amount of shallow coastal waters. These coastal habitats are vital nurseries for marine life, rich in nutrients and sunlight. With their disappearance, marine ecosystems became less productive and more vulnerable. The single massive ocean, Pangaea, had different circulation patterns than our modern oceans, which likely led to areas of low oxygen, particularly in the deeper waters. The seas, like the land, were becoming a more challenging place to live, setting the stage for a crisis. The sheer scale of Pangaea meant that climate was not uniform, but varied dramatically with latitude and proximity to the coast. The coastal regions might have experienced seasonal monsoons, bringing torrential but short-lived rains, while the polar regions were cold and subject to glaciation, at least in the early Permian. This created a mosaic of different environments, but all were subject to extreme fluctuations. Life had to adapt not just to one harsh condition, but to a world where stability was the exception, not the rule. This constant environmental stress made the ecosystems of the Permian inherently fragile. Despite the harsh conditions, life during the Permian was wonderfully diverse and innovative. This was not yet the age of dinosaurs but the age of synapsids, our own distant ancestors. These creatures are often mistaken for reptiles, but they were on a different evolutionary path, the one that would eventually lead to mammals. Great sail-backed creatures like Dimetrodon, a formidable predator, roamed the land. It used the large sail on its back not for defense, but likely to regulate its body temperature in a world of climatic extremes, warming up quickly in the morning sun and cooling down in the oppressive midday heat. On the plains of Pangaea, large, barrel-bodied herbivores known as casids were some of the first truly large land animals to feed on tough, dry vegetation. Alongside them were the fearsome Gorgonopsians, saber-toothed predators that were the apex hunters of the late Permian. These were powerful, fast-moving carnivores, perfectly adapted to hunting the large herbivores that populated the arid landscapes. The world was filled with these strange and wonderful creatures, each one a testament to life's ability to find a way, even in the most challenging of settings. They represented a complex and mature ecosystem. In the seas, life was equally varied. Coral reefs existed, though they were built by different organisms than the corals we know today. These reefs teemed with life, including strange-looking coiled ammonites, relatives of modern squid, and vast numbers of brachiopods, shelled creatures that filtered food from the water. The waters were also home to bizarre sharks like Helicoprion, which had a spiral-shaped whorl of teeth in its lower jaw. Marine reptiles were just beginning their evolutionary journey, with early forms showing the first adaptations for a life spent in water. Yet this diversity was built on a precarious foundation. The plants of the Permian had to be incredibly tough to survive. The lush fern-filled swamps of the Carboniferous gave way to hardier plants like conifers, cycads, and glossopterids. These plants had features like tough, waxy leaves and deep root systems to cope with the widespread aridity and dramatic temperature swings. They formed the base of a food web that was constantly under pressure. The entire system, from the smallest plant to the largest predator, was finely tuned to a harsh world, but it lacked the resilience to withstand a truly catastrophic shock. As the Permian period drew to a close, the environmental stresses that had defined the era began to intensify. The planet was already a difficult place to live, with its vast deserts and volatile climate. Ecosystems on both land and sea were walking a tightrope, finely adapted to their harsh surroundings, but with little margin for error. The world's climate, which had been gradually warming and drying for millions of years, was now approaching a tipping point. The forces that had shaped the Permian world were about to unleash a catastrophe of unimaginable proportions, a storm that had been gathering for an entire geological age. The vulnerability of Permian life was its greatest weakness. On land, the food webs were relatively simple compared to modern ecosystems. Large herbivores depended on specific types of tough, arid-adapted plants. The formidable predators, in turn, depended on these herbivores. If the vegetation were to collapse, the entire structure would crumble with it. There was little redundancy. This lack of complexity meant that the ecosystem was brittle. It could withstand the regular, predictable stresses of the Permian climate, but it was not prepared for a sudden, overwhelming change to the system. In the oceans, a similar fragility existed. The loss of shallow coastal seas when Pangaea formed had already concentrated marine life into fewer, more vulnerable habitats. Many marine communities like the reef systems were highly specialized. They depended on stable water temperatures, oxygen levels, and chemistry. Any significant disruption to these factors could lead to a widespread collapse. The deep ocean was already prone to becoming anoxic, or oxygen-deprived. This lurking threat meant that even a seemingly small change in global conditions could trigger a deadly cascade through the marine realm. The stage was now set for disaster. Life, both on land and in the sea, had adapted to the very edge of what was possible. It was a world of specialists, each perfectly suited to its niche in a difficult environment. But this specialization came at a cost. When the environment changes slowly, life can often adapt and evolve in response. But the end of the Permian would not be a slow change. It would be a sudden, violent, and global cataclysm that would overwhelm the coping mechanisms of even the most resilient creatures. The gathering storm was about to break. The storm broke in what is now Siberia. Around 252 million years ago, a series of volcanic eruptions on a scale never before seen by complex life began. This was not a single volcano but a vast volcanic province known as the Siberian Traps that spewed molten rock and gas for hundreds of thousands of years. The sheer volume of lava was staggering. It covered an area larger than Western Europe and was, in places, kilometers thick. But it was not the lava that dealt the deadliest blow, it was the colossal amount of greenhouse gases, particularly carbon dioxide and methane, that were released into the atmosphere. This immense injection of carbon dioxide triggered runaway global warming. Global temperatures soared, perhaps by as much as 10 degrees Celsius. On land, this intensified the already arid conditions, expanding deserts and causing widespread droughts that killed off the hardy Permian flora. The base of the food chain was obliterated. In the oceans, the rising temperatures had a devastating effect. Warmer water holds less dissolved oxygen, and the ocean circulation system stalled. This led to a condition known as ocean anoxia, where vast swaths of the sea became deadly, oxygen-starved zones, suffocating marine life. The horror did not stop there. The volcanic eruptions also released other toxic substances, such as sulfur dioxide, which would have created powerful acid rain. This acid rain would have poisoned the soil and acidified the surface waters of the ocean, making it difficult for organisms with calcium carbonate shells, like brachiopods and corals, to survive. To make matters worse, the warming of the seabed may have destabilized frozen methane hydrates, releasing even more potent greenhouse gases in a catastrophic feedback loop. The world was being attacked on multiple fronts, by heat, by suffocation, and by poison. This confluence of disasters is what made the Permian-Triassic Extinction so uniquely devastating. It is often called the Great Dying, and for good reason. It was not one single event but a cascade of environmental collapses, each one amplifying the others. The planet's life support systems were failing. The volcanoes initiated the crisis, but it was the chain reaction that followed. Global warming, ocean anoxia, acid rain, and further methane releases that pushed life to the very brink of total annihilation. It was the Earth's ultimate nightmare, a perfect storm of destruction. The impact of the Great Dying was swift and brutal. It was the closest life has ever come to being completely wiped out. Scientists estimate that up to 96% of all marine species and 70% of terrestrial vertebrate species vanished forever. The oceans were hit the hardest. The vibrant reef ecosystems, which had taken millions of years to develop, were completely destroyed. Trilobites, which had survived for over 270 million years, finally met their end. The vast communities of brachiopods, sea lilies, and other filter feeders that had dominated the Permian seafloor were decimated, leaving behind a barren, silent world. On land, the devastation was just as profound. The great synapsid empires crumbled. The large herbivores deprived of their plant food sources were among the first to go. Without prey, the fearsome Gorgonopsian predators soon followed them into extinction. Entire families of insects disappeared, the only known mass extinction of insects in Earth's history. The once diverse forests of hardy Permian plants withered and died, replaced by simple, weedy fungi that thrived on the immense amount of decaying organic matter. For a time, the world was covered in little more than a fungal wasteland. The few survivors inherited a broken world. On land, one of the most successful survivors was a small, pig-like synapsid called Lystrosaurus. This creature was not particularly large or fearsome, but it was a hardy generalist. It was a burrower, which may have helped it survive the initial heat and environmental fallout. In the aftermath of the extinction, with most of its predators and competitors gone, Lystrosaurus spread across the desolate landscape of Pangaea, becoming for a time the most common terrestrial vertebrate on the planet. Its survival is a lesson in how sometimes the meek truly do inherit the Earth. Recovery from this event was incredibly slow. It took millions of years for ecosystems to begin to rebuild themselves. The sheer scale of the extinction meant that the building blocks of life were gone. It would be more than 10 million years before complex ecosystems like forests and reefs would re-emerge. The world that eventually arose from the ashes was a very different place. The dominance of the synapsids was over, and their extinction cleared the way for a new group of reptiles to rise, the dinosaurs. The Great Dying did not just end a world, it created the opportunity for a new one. The Permian was Earth's ultimate nightmare because it represents a time when the planet's own geology turned against life in the most violent way imaginable. The harsh, unrelenting pressure of its climate, combined with the inherent fragility of its ecosystems, created a world that was primed for collapse. The Great Dying was not just an extinction, it was a near-total reset of the biosphere. It demonstrates that even complex, well-established ecosystems can be completely undone when faced with rapid, extreme environmental change. The permanent nature of this nightmare lies in the fact that its effects were so profound that they reshaped the entire course of evolution. The story of the Permian holds a critical lesson for us today. The trigger for the Great Dying was a massive release of greenhouse gases into the atmosphere from the Siberian traps, which led to catastrophic climate change. Today we are releasing carbon dioxide into the atmosphere at a rate that is perhaps even faster than what occurred during those ancient eruptions. We are witnessing rising global temperatures, ocean acidification, and the increasing frequency of anoxic dead zones in the sea. The parallels between the end of the Permian and our current trajectory are undeniable and deeply sobering. While we are not living in the Permian, the principles of ecosystem fragility remain the same. Our planet's biodiversity is a complex web of interdependencies, and as we push species to extinction and destroy habitats, we are removing threads from that web. The Permian teaches us that ecosystems have tipping points. They can absorb a certain amount of stress, but once a critical threshold is crossed, the collapse can be sudden and catastrophic. We are currently testing the resilience of our own global ecosystem in an unprecedented experiment, the outcome of which is unknown. Reflecting on the Permian is not an exercise in ancient history, it is a vital warning. It shows us the immense destructive power of rapid climate change and reminds us that our planet's stability is not guaranteed. The empty world left behind by the Great Dying took millions of years to recover, and the life that returned was utterly different from what had been lost. The Permian stands as a stark monument to the fragility of life. It is an echo from the deep past, urging us to understand the profound consequences of our actions and to protect the only biosphere we have.